Good afternoon, everyone, and thanks for joining today's webinar. Very happy to be here with my colleague, Alexandre Boumezoued, to talk about some real-world AI applications in actuarial departments. Some quick introduction. So my name is Joe Sloan. I'm a consultant actuary with Milliman. Alexandre is also an actuary, and he's a principal and research and development director at Milliman. Before we get to all the interesting stuff, a few housekeeping points to cover. The webinar is being recorded. I think it will be available on ActiveView and YouTube afterwards. The presentation itself will run for about 45 minutes. We'll have some time for Q&A at the end. We promise to finish by 2 o'clock. The Q&A session will also be recorded, and you can submit questions at any time using the Q&A portal, which should appear at the bottom of your screen. Questions can be posted anonymously or with your name. If we don't get to your question during the session, we'll do our best to follow up afterwards if there's a name attached to the question. A quick reminder as well that once you register your full name, the Society will have a record of your attendance. I appreciate the CPD scheme no longer requires verifiable CPD, but some other organisations might need the record. I'd also like to thank the Society, and in particular Gerard Bradley and the Data Science Committee, for giving us the opportunity to speak on AI and being a champion of the topic generally. I was at the convention a couple of weeks ago now at this stage, and it was fantastic to see so many high quality sessions and discussions on AI, and it was clear that the area is getting a lot of traction. And hats off to the Society and the organisers for keeping it high on the agenda. With these formalities out of the way, we can move on to today's topic. So, real-world applications of AI in actuarial departments. Milliman has made a very significant investment in AI, and Alexandre leads our European AI Centre of Excellence. His team is multidisciplinary, so it comprises of actuaries, people with PhDs in AI and machine learning, data scientists, IT, and so on. And over the past number of years, our focus has been on building expertise in large language models, LLMs, and generative AI generally, and then focus on how to apply those to the insurance industry. Over that period, we've done quite a lot of work with companies in actually implementing the real world AI solutions so that they can see the tangible benefits of AI and have a competitive advantage. To back all that up, Alexandre will take you through 4 case studies, show what this looks like in practice. He'll cover 4 different areas that actuaries are normally involved in: production, checking, explaining, and monitoring. A couple of last bits of housekeeping that I forgot about. The views expressed here are our views, not necessarily the views of our employers and the Society. And the next slide, please, Alexandre. And the presentation will primarily touch on these key competencies. So before I hand over to Alexandre, let me set the scene a little for Ireland. We've run a number of surveys this year on the insurance industry where AI was in scope. On the left, you'll see results from a survey of 37 CEOs of Irish companies. And on the face of it, it's clear that AI and machine learning is being used in the sector. But when you dig a little deeper, most of the deployments are still in pilot programs or specific use cases. Really, enterprise-wide adoption is very much still developing. And then looking at it from a different perspective, so an actuarial modeling perspective, another survey that we ran shows that over 70% of companies expect AI to influence their actuarial modeling in the next 5 years, but they have no specific plans around it yet. Only a small subset have concrete plans on how to use it. So still a very significant challenge, a big gap to close before AI becomes embedded in actuarial processes. So with that context in mind, I hope you find the session interesting, and over to you, Alexandre.
Thank you, Joseph. Thank you very much for having me here. So a quick intro on Gen AI models before we go into more details. So just a reminder that the GPT revolution is from 2018, therefore 4 years before the launch of ChatGPT. So the quotation you see here is from the famous paper from OpenAI. So this paper, published in 2018, introduced GPT as a technique. So that's for generative pre-training. And that's a breakthrough because that's the first time we succeed to build a general model that is therefore task agnostic, however, which outperforms other models that are specifically designed for their own tasks. So that's a breakthrough because through a general model, you are able to have a general architecture and a so-called pre-trained approach, which makes them the general model usable in a variety of applications. So just note that the 2018 paper has been followed by many developments. As you know, the GPT 2, 3, and then 3.5 behind ChatGPT and many other models in the market as well. So large language models are therefore general models, so they are not specific to a given task, but they are good at very different tasks as well. So you see in this graph how LLMs perform when it comes to software engineering tasks. So on the x-axis, you have the LLM release date with newer and newer models. So you can notice GPT 3.5 in 2022 with ChatGPT and newer models more recently. On the y-axis, you see a time, which is in fact the duration of a task for a human to complete. So for example, implementing something like a simple web server will take a software engineer around 20-25 minutes, which is explained on the y-axis. So the purpose of this graph is to show how LLMs are able to complete tasks that take some time for humans. And as you can see in this graph, while before 2024, LLMs were not able to complete accurately tasks that were around minutes, now they are able to complete tasks that will take a software engineer around 30 minutes. So that's interesting, and you see how this is increasing exponentially. So more and more models are now able to capture longer tasks. However, when it comes to actuarial processes, we know that those actuarial processes are not just 30 minutes. So we need to work a little bit more to make those general models specialized to actuarial tasks and allowing those models to complete actuarial tasks of a long period. Therefore, the key question before we go into the case studies is the following. How can we make a large language model, which is a general model, specialized to the actuarial domain? And there are three techniques that allow to make a general model specialized into an actuarial task. And the first technique is to ground the knowledge of the model in actuarial information. This step is critical because otherwise you cannot build a model that is able to perform actuarial tasks and actuarial processes. So how to ground knowledge of those models into actuarial information? Basically, you may have seen that already, but it's called the RAG, Retrieval Augmented Generation, which is one of the possible techniques to improve the accuracy of the large language models because they are forced to look for information in a prescribed set of documents or in data sources to provide you with an answer. So this is critical as you will make the model more specialized because the knowledge of the model is actuarial based. But that is not sufficient to get a model that is able to empower actuaries. Why? Because if you do nothing else more than grounding knowledge in information, the model is not able to perform reasoning for actuarial tasks and the actuarial domain. So how to allow models to perform reasoning dedicated to actuarial tasks? Typically, we do have the so-called AI agents that you may have seen already. So what are AI agents? Those are autonomous systems that are capable to develop action plans, to make decisions, and then to perform actions to achieve their goal. In fact, they are even able to think about the outcome of their actions and how to improve them to achieve the specific goal they have in mind. So AI agents are just some form of prompt engineering and in advanced engineering on top of a large language model, but it allows large language model to perform longer tasks because it allows them to perform reasoning, plan, make actions and decisions. But then again, if you have a system that has the actuarial knowledge and is able to perform actuarial reasoning, we need something else. We need to allow those models to access the ecosystem of actuarial tools, because ultimately what we want to achieve is the transformation of actuarial processes. And actuarial processes are made of some kind of information, are critical related to reasoning, but they are made intrinsically of actuarial tools, and we need to find a way to connect large language models to the actuarial tools. There is already a standard to do that, which is called Model Context Protocol. That's a new standard to make any tool accessible by large language models, or to access also external information for a large language model. But critically, it has become a standard if you want to have an AI agentic system access an ecosystem of actuarial tools. And I'll show you one example of that as well. So in a nutshell, how to specialize GenAI to actuarial tasks? We need three components and three techniques. And on the case studies I will show, I try to mention which are the kind of techniques that are used in each case. So as my colleague Joseph already mentioned, we are going to show you use cases on four main areas. Those cases are either proof of concepts or put into production at some clients in the insurance industry. And you will see where the market is in terms of adopting AI system and adapting those to actuarial tasks. So the first case study we will show is how to transform the actuarial production chain. That will be through a video that shows you how MCP works when it comes to having an LLM connect to an actuarial cash flow model. The second use cases we will show is the checking. So how we can use AI to better control the outcomes of the actuarial model, and in particular comprehend actuarial formulas within actuarial specifications to then check that an actuarial model is correct. The third use case is about reasoning. So we will show a system in production helping actuaries to analyze and communicate the results with the example of IFRS 17 analysis of movement, but which can be extended to many other use cases as well. And finally, we will conclude with a case study on risk monitoring, so showing how actuaries can be empowered with systems that are able to digest external information and build risk indicators so that actuaries can track the risks the company is facing. So the four case studies will be showcased by illustrative examples and some videos to make that a little bit more fun, therefore. So let's start with produce and the production use case, which will be through a video I will explain. So the objective of the use case is to show you the benefit of the so-called MCP, Model Context Protocol, that we discussed just before. And it's also an example to show you how, in fact, straightforward it is to make an LLM understand an actuarial model and what we can do with it once we connect. So I show you the use case now. So the use case is the following. On the left, you do have a chatbot. That's a general chatbot. Here it's Claude from Anthropic, but could be another chatbot like ChatGPT. On the right, you have an interface, which is the interface of a cash flow model, ALM model, coded in Python, but that makes no specific impact to this use case. So on the left, you have a chatbot. On the right, you have an LM cash flow model. And if you do nothing, there is no connection between the large language model on the left and the cash flow model on the right. But thanks to MCP, the so-called Model Context Protocol, you can explain to the large language model what it takes to use the cash flow model. So when we say MCP, it means that we are encoding the way the cash flow model works, but we are doing it in a way that LLMs can fully understand. So what can we do with that? Once the MCP is built and the two are connected, it means that the LLM can digest instructions that relate to the cash flow model. So here we show one instruction, which is please run the lapse sensitivity, and there is nothing else to do because the large language model knows what it relates to and what is it about. So as you can see, the large language model performs tasks which are here creating the right workspace and running the right run, therefore retrieving all the outputs, and the job is done. So we go from a natural language instruction to a real use case just by having the MCP. But of course, that's more. Now, once the LLM knows how to use an actuarial cash flow model, you can ask everything. So for example, if we move one step forward, you can say, could you please modify the shock and apply, therefore, a shock to the lapse assumption, which is 1%. So the new task understood by the LLM is to create a new workspace, change the lapse assumption, apply a 1% shock to the lapse assumption, save the lapse assumption, perform the run again, retrieve the outputs. So we are just showing here that indeed the new workspace includes a new lapse assumption with a new shock. So this very specific example is to show you how we can transform the actuarial production chain, and there is already in the market use cases like this, where in fact, indeed, we are helping clients to orchestrate the actuarial production chain. And for example, if you have a key question strategic to answer, like what's the sensitivity to the market environment, you will have an agentic system that is able to perform the runs that are required to understand that. Can be an analysis of movement and a step-by-step run production, changing one by one the economic conditions. So as we have seen, we have already the technology to make large language models perfectly understand the models and how to use those. So that's the production use case. Let us now switch to the check use case. So the check use case is inspired from the aeronautics industry. So in the aeronautics industry, there is a concept which is called formal verification of systems. So any critical system that goes into a plane by aeronautics regulation shall be submitted to this process, which is called formal verification. So formal verification is the process by which we ensure that a model is perfectly accurate compared to its specifications. So it's not just about checking models in one or two scenarios or building an Excel mirror file. It is about having a model spec and ensuring that the model is exactly following the model spec in any situation. Now, if we look at an actuarial cash flow model, it's true to say that the universe of unstructured information is wide, against which we need to ensure that the model is correct. For example, regulation, Solvency II delegated acts, for example, are documents to which the actuarial model shall relate and shall comply. The technical specifications of the model, or even the contracts, for example, where we have to ensure that the cash flow model is parameterized the right way. So where AI is interesting is typically on handling unstructured information. So when we do have information that is not exactly a table of figures, AI is quite good at, and we will show examples where AI can be designed to help actuaries to check the model. So we take here a very special example, though the use case is more general. We look at the delegated acts and we look at the table which prescribes the shocks to apply to calculate the spread risk SCR with the standard formula. So we have this table in the document, and more generally, we process the PDF. So there is an AI system, and I will explain which kind of system that is able to digest this information. So what is this information? That's a PDF document. In the PDF, there is a table. In this table, there are coefficients, A and B, there are values, and there are formulas. So for example, depending on the duration of a bond and its credit rating quality, I know that I need to apply this formula A plus B times, etc., which depends on the value of the coefficients. So that's a very complex information, which actuaries do absolutely understand, and actuaries can manually look at it to check the outcomes of a model. But what we want to do here is to help actuaries with a system that is able to do that already. So which kind of system? We need a system, an AI model that reads the table, and reads being looks at all the pixels, and derives a comprehensive table where it knows which values to use in which case and which formula to apply. So large language models are good at language, so they are not really good at reading formulas off the shelf. So we will turn to other models to achieve this task. So there are other generative AI models that are not large language models, but that are vision models. So vision models read pixels instead of reading language. So you know that there are generative AI models for images in particular. Here it's a little bit special because that's a generative AI model which is designed to read formulas explicitly. So when we say read formulas, it's really reading pixels. What I show here is how that model has been trained. So it has been trained on millions of scientific articles showing very different type of content. And for each article, a large number of alternative articles have been built by the provider of this model to then recover a very large dataset of millions of articles that are then multiplied by the number of variations. And those variations are here to create resilience within the model because, as you can see, it relates to distorting the original paper to make things less clear or distorted, etc., which makes the model training more resilient. But in the end, what you get is a model that is able to read actuarial formulas and truly understand the mathematics. So this is to show you how AI can in fact read actuarial specs and then apply checks to an actuarial system. And that's an example which is indeed running in one specific environment. So we have systems that are good at learning and understanding actuarial formulas. That's one point. But we also need systems that are able to understand typical information which is within actuarial systems, such as stochastic paths. So just a pause here. I show you one figure which is within a paper that is a breakthrough in video recognition. So as you know, Gen AI systems are developed for language, for images, but also videos, and in particular video classification. So here it's about being able to recognize a movement. So the person is raising the left arm on this example. And the question is how to build an AI system that is able to understand that indeed we have a person that is raising the left arm. So the paper introduced the concept of signature. So it's really difficult to understand trajectories in general, which makes actuarial systems also quite complex because we have stochastic paths being risk neutral or real world. But then in this paper, we have a technique that shows that if we build a feature, which is the signature, we are able to better understand the stochastic paths. So this idea has been applied in the actuarial domain to help actuaries verify stochastic paths, and I will show you how you can turn qualitative expert judgment into a quantitative test for actuaries. So I show you an example of this model where on the left you have an historical path of US inflation, so the historical path, and on the right you have different models that are submitted to the actuary. So the actuary receives different types of stochastic paths, either from a given model 1 in orange or another model 2 in green. So the purpose of the statistical test built from this concept of signature in the GenAI space is to help the actuary to test if a path, a stochastic path in the actuarial model is reasonable or not compared to the historical evolution of the risk factor. And here, as you can see, the testing is able to reject the model in orange, which was too simplistic, while accepting the stochastic path in green that can then be input into the actuarial model. So that's a very important breakthrough as well, because sometimes validation of economic scenarios, and here stochastic real world, say for strategic asset allocation, is really expert driven. So this example is to show you how we can improve and augment the expert with quantitative tests, even if the information is not structured as usual. Another typical example is volatility. So you have in blue a path of real-world volatility for the S&P 500. And on the right, you have two scenarios, one built from a standard model in orange and one built with a more advanced model in green. And as you can see, the model in green is likely to be better because it reproduces the typical spikes in the historical data, spikes in volatility. So the aim of the test is here to help the actuary to assess if the model or the trajectories that are input to the actuarial model are correct when it comes to reproducing the features from the historical data. And as you can see, the orange model is rejected while the green model is accepted. And this is only based on the quantitative test, and it kind of replaces or at least complements the expert judgment we could make, saying that we would rather perform our strategic asset allocation or SCR calculation in internal model with the green model as opposed to the orange model. So this example is also to show you how control tasks can be augmented when it comes to absorbing documents, as we have seen with formulas, but also looking at other type of information like the full stochastic path we have to input to the actuarial model. So this was a second use case to show you again how AI can leverage information, larger information, to perform controls, and we have seen dealing with actuarial specs and documents, and we have seen dealing with paths. So the third use case is about reasoning, and that's, I would say, the most difficult one, and we will explain why. So large language models, as we have seen, are general models. They have not been built for a specific domain. But also, large language models have not been built to perform reasoning. They have been built to understand relationship between words and to produce sentences and responses that are based on the likelihood of words to occur. So the core reasoning capabilities are not within large language models, and this is already known. You can see here a famous paper by Apple Research, where the researchers have shown that indeed large language models are not capable of gaining logical reasoning, so cause and effect relationships. Instead, they do attempt to replicate what's going on in the training data. So when it comes to actuarial tasks, and I'll take an example which is actuarial reporting, we need to describe in the actuarial reports the cause and effect relationships and the true and explain the true behavior of the model. So one approach that would not work to help actuaries is to say to an LLM, here are past actuarial reports, and please help me to build a new report from the new data. And why this approach does not work? Because this lack of core reasoning of LLMs. They are not able to perform reasoning. They will just attempt to reproduce the kind of style, tone, and key facts observed in the training data or the context data. So what can we do? So I'll come back to AI agents and I'll try to explain you how we can. So here on Solvency II, but I show you an IFRS 17 example as well, how we can design AI agents to follow the actuarial reasoning instead of using an LLM to be creative, because we want to have a system with no hallucination. So we want to have a system that follows the actuarial reasoning as opposed to be creative from past information. So let's be an AI agent. So you do have all the results, Solvency II results of the cash flow model, and you are an AI agent. So what do you do as an AI agent to help the actuaries? If you want to build such a slide as an AI agent, you will be taught to first build an executive summary. So here the own funds for Euro contracts evolve this way, and this is your main outcome. But then as an AI agent, your core objective is to build an executive slide that explains exactly what happened in the cash flow model. So as an AI agent, you will do what we call level one analysis. So we'll try to look for all the risk drivers that are impacting the balance sheet, and you will leverage fully all the information from the analysis of movement. So here you'll say, okay, I see that changes in the swap rate, and you will grab information about the economic conditions. So say the 10-year swap rate increased by X bips. The impact of swap rate changed as is this one in million for the own funds. Then as an AI agent, you also know that you need to deliver the full analysis and the full understanding. So if you say this risk driver has an impact, as an AI agent, you'll have to explain why. Why? For example, there are multiple impacts of having a swap rate change. One of the impacts is duration, but there are many others. But you will explain exactly, as an actuarial expert will do, what exactly happens within the model. And this is what we call level 2 analysis. That's the why exactly this has been observed in the own funds. So why am I discussing that is to let you know that the systems that are now in production, because they are in the European insurance market where AI is fully integrated and the actuarial reports are fully automated, ready for review, is that a prerequisite to leverage AI is to formalize and document the expert reasoning. So there is no AI in that step, but that's so important to have a proper documentation and formalization of what is exactly the reasoning process of the actuaries when it comes to understanding Solvency II results, or on this example, providing an analysis of the movements of the balance sheet for IFRS 17. So I show you another real use case in production where the system is able to produce many slides on IFRS 17, but in particular analysis of movement. And so the process to design such system is the following. First, you formalize the expert reasoning. So you write down the actuarial algorithm to analyze movements. So here again, the CSM analysis of movement, for example. And then you develop an AI agentic workflows that exactly applies this approach. And this contrasts with another alternative, which will be, again, here are the past reports, here is the new data, please, the LLM, produce a new report from this information, and this will not work because the LLM cannot perform reasoning. Instead, you'll design an agentic workflow on top of the LLM that strictly applies actuarial reasoning. So the benefit of that is, of course, a strong management of accuracy because you avoid to rely on creativity of LLMs and you perform true reasoning through agents as opposed to mimicking reasoning through the LLM directly. So on this example, and that's exactly the kind of fully pre-automated analysis from the GenAI system and the AI agents, you can see that you have an analysis of how the business volume, how the profit margin impacted the CSM movements, and how that's linked to underlying indicators like the average commission rate, etc. So you can get very refined analysis from the GenAI system, provided that, again, and that's the key takeaway, you have AI agents that perform reasoning instead of having LLMs that are creative from past reports. So I will show you another way to leverage AI agents. So far, we did not discuss chatbots, although chatbots are everywhere. And in fact, if you look at those systems that are capable to issue actuarial reports, the same systems can be leveraged within a chatbot to empower actuaries in their daily tasks. So I'll show you one specific example where we have developed a chatbot that is expert on economic scenario validation in particular, to which the actuary asks for a comparative analysis of the ESG validation results between 2 quarters. And so as you may have seen, the chatbot says, well, the previous quarter it was green, the new quarter it's red, and then the user asks why. So where AI agents play a critical role is for those kind of questions. Why we do see a validation that is red while it was green before. So the resulting analysis which appears here is exactly the result of the AI agent reasoning. So the AI agent is expert on ESG. It has been developed by our ESG team. And it goes level by level and data by data to draw a full comprehensive analysis of what happened. And one of the key conclusions is that there is kind of an issue in terms of market consistency for interest rates. There is also something on correlations, but I'll discuss the market consistency aspects. So the chatbot is ground into actuarial knowledge on ESG data, but there is also an agent that is able to perform analysis and knows what martingale, market consistency, and correlation tests are. So the benefit of a chatbot for an actuary is then to dig into more detail. So you can ask, for example, to draw a plot of the errors between the market swaption volatilities and the model swaption volatilities because you want to understand if there is a calibration issue in your own ESG. And while doing so, it's not the expert agent that answers, but the agent that is capable of graph production. So this agent will issue a graph from the data. So it will collect the data, perform differences, and issue a graph. And you can see here the 3D plot. So the graph production is not predetermined at all. That's created on the fly by the graph agent. The graph agent is empowered with auto verification layers, which is critical. So the graph agent produces a code that then produces the graphs with verification layers in between. So this kind of chatbot shows you one example where you have a technology that is helping actuaries in a workflow. Say it's able to access tools, it's able to perform controls on the model, it's able to produce reports. But the same technology can be leveraged within a chatbot, and the actuary can then ask questions not only about data, but also about analysis, and then the chatbot will perform the actuarial reasoning tasks. So I will now conclude with a final use case on risk monitoring, just to give you a flavor of what again is going on in the market in terms of technology and usage of GenAI. So the specific example I'll show you is on geopolitics, though the example is more general. So as we know, geopolitical risk is a critical risk, and you may want to follow that risk as an actuary if you are about making decisions on the asset allocation, or you are managing the balance sheet. And we know how external information, and in particular news, are informative to our risk. So beyond financial data, external information that is not structured is also critical to capture the risk. So I show you here some headlines and articles from the New York Times. In fact, the New York Times, as example, has a large data set you can leverage. And so in particular, you can access up to 13 million headlines, sometimes the article with it, which is a huge data set. So what can you do with this data set? You can perform what we call sentiment analysis. So you'll have experts that will label few articles and understand their impact in terms of geopolitical impact. They will put +1 if that's an increase in risk, -1 if that's a decrease, and 0 if that's neutral to geopolitics. And then you will train a GenAI model on this data set, which you will apply to all the data and news feeds moving forward. So what are you doing? You are building what we call a sentiment index. So if you look at this index that has been built by our teams as example, you see that the index exactly follows the geopolitical tensions. And in particular, if you apply such index moving forward, you'll capture in real time the level of geopolitical tensions informed by news feeds. So this is on geopolitical risk, but it can apply more broadly. And in particular, there is work going on in the market around typical actuarial risk, such as inflation for the health insurance covers. So thank you very much for your attention. I hope you found the use cases insightful and interesting, and I'm happy to discuss with my colleague Joseph any questions you would have.
Thanks a lot, Alexander. Some great applications of AI there. I'm also personally very relieved that the videos played without a hitch. They weren't doing so 1 minute before we started, so it would have been a bit ironic to have tech problems during an AI webinar, but we took a gamble and it paid off. So we do have some time to answer a few questions. Just a reminder to pop them into the Q&A portal. I'll try my best to pick up some common themes there. As I mentioned before, if we don't get your question and you don't feel we've answered it, or we don't feel we've answered it, we'll try to follow up if your name is on the question. So maybe one question to get us started, Alexander, and it's kind of a popular question that comes up in AI presentations, is around reliability of models. Any insights there around how best to ensure AI models are accurate and reliable?
Yeah, that's an important question. So in particular, there are two ways to ensure that those systems are reliable. One is by design, because again, as you will design AI agents that are able to follow the actuarial reasoning, that's one by design way to ensure that you do not rely on LLM's creativity when it comes to reasoning, while you will leverage LLM capabilities in terms of large-scale data screening and creativity when it comes to explaining or summarizing, but you'll force the AI system to follow reasoning. So that's kind of a by design approach to accuracy. And one maybe other approach is really a posteriori. So of course, actuaries are here in all steps of the system development, but they are here to validate the final system. And just for information related to that question, there are methods that are able to compute performance metrics like we have for standard statistics, but apply to chatbots and automated reporting processes. So we are computing accuracy metrics that we closely follow when the systems are in production as well.
Thanks, Alexandre. It does feel like demonstrating reliability and accuracy is obviously going to be crucial for getting those testing models over to production. Maybe building on that slightly, another question is around, now that some of those case studies are in production, any advice on what the key success factors were for those AI projects?
That's a good question. I think it's a question that is shared by many in the market. I would say from more experience, one of the key success factor is to build alignment and engagement at different levels in the company. So first, within the actuarial teams, we have to identify the AI enthusiasts or the AI champions that are really willing to move forward. That's one critical aspect. The second aspect to build this alignment is also to get some support from the top and even a top-down strategy on having AI within the actuarial tasks embedded. So that can be up to the executive committee, but having this top strategy is also essential. And I will also add as key success factor, which is around still building alignment, is putting the actuarial use cases in the company's roadmap. So we have seen a lot of use cases around the client and customer journey in insurance where we leverage AI, but it's also critical as we have seen that the actuarial teams do have their actuarial use cases in the company roadmaps, which builds also support from the AI labs and the IT to do the use cases. So I would say the key success factor is really to align the actuarial teams, a top-down support, and the IT AI lab so that everyone is aligned on the same objective.
Super. Maybe taking a slightly different direction, and hopefully you don't mind if I put you on the spot for a more technical question. There's an interesting one here asking, did you test different LLMs? Any feedback on what worked best?
Okay, that's also a good question. So first comment, the newer models are really more and more intelligent. So that's obvious. They are more accurate. They are more complex. There is an increasing benefit in using the very latest models. So that being said, it means that yes, there are really different performance metrics per model, and therefore, if you have, say, a chatbot for actuaries that leverages one model or another, you'll have differences. So we have techniques to measure those differences, but we have also an approach to maintain the solution over time. So the key question is, how do you keep up with the new models arriving and how you make the system evolve with the new models, because there is a clear benefit in doing so. But those are the kind of questions that are tackled in the work we are doing indeed.
And looking at a different area, so I guess the questions are quite wide ranging, which is probably indicative of the audience that AI gets. So there's one on risk here. I suppose it wouldn't be an actuarial presentation without a mention of risk. And the question is, how are risk departments adapting to increasing adoption of AI? I guess from my perspective, anyway, at least, Alexander, and this is a pretty sweeping statement or generic statement, I think there is a good bit of room for improvement. So whether that's updating your risk policies or risk appetite statements, including things like new risk indicators and controls. And I guess a good first step that even some companies are taking is even just to simply document what companies want and will allow employees to do, especially where there's this kind of grassroots adoption of AI. Documenting that, but even the more complicated pieces around the validating AI models and so on. More questions. There's one on, is there a significant upfront effort and cost required to start using these AI applications?
That's an interesting question as well. I will come back to this point on building alignment because once alignment is built, we have seen interestingly how smooth and efficient it was to build the first actuarial use cases. So once there is a top-down strategy, the AI lab is on board to make everything possible in terms of accessing the catalog of AI models. And once you have some AI enthusiasts in the actuarial team that will be here to test the system, etc. So of course, external support may be required. So, but yeah, it's quite easy. There is no huge cost at starting once alignment is built.
Thanks. And maybe one final question we can squeeze in. Any tips for ensuring data security and privacy of proprietary data when incorporating AI models into existing actuarial practices?
Yeah, that's a very important question as well. So typically, insurance companies in Europe will work with vendors of Gen AI models, such as Microsoft Azure, such as other models that are provided through Azure or say through Anthropic or Mistral, etc. So those providers do build relationships with insurance companies to ensure that all the prompts and the data is absolutely not processed. So which by contract and by design will make the use cases possible. So usually that's the responsibility of the IT or joint ownership between IT and AI lab within insurance companies to ensure that this governance is applied.
So I think that's most of the questions answered. I'm kind of conscious of time, so we might leave the Q&A there. If you have any questions after the presentation, feel free to get in touch with myself or Alexander. So we might just wrap up. So I guess thanks to Alexander for your presentation and for tackling some excellent questions there. Thanks to everyone that joined over your lunch break and for your engagement during the webinar. I hope you found it interesting. And just one final thanks to the Society and to Sim for ensuring everything ran so smoothly. So we might leave it there for today. Enjoy the rest of your afternoon and thanks everyone.